Okay, for my try it, this is how I did it. I added 7 to the middle part, so I added 7 to both ends. And then I had to divide by 2. It was 2a, so I divided by 2 everywhere, all 3 places. And I got a has to live between 9 halves and 10, not including 9 halves, but including 10. And so here's my graph. So that value that will work in the original equation has to be between 9 halves and 10, but not including the 9 halves. So call it a between inequality. You shade between the 2 dots. All right, and I started this next one. My computer crashed, so hopefully I didn't get too far ahead here. I think it'll be fine. So this is an and compound inequality. This is the second type out of the 3. You have x is greater than or equal to 3 and x is less than 10. So what I'm going to do here is I put my 2 kind of endpoints here. And I'll tell you that 95% of the time in and inequality, you're just going to shade between them. And that's what's going to happen here as well. But I just want to let you know that. Every now and then you'll get one that's weird. Okay? So what I want to do is kind of look in all 3 zones. I want to look here first. Let's say at 1. And see if 1 works in both of these, this and this. Is 1 greater than 3 and 1 less than 10. So I take my number that's in this area, and I say is 1 greater than 3 and 1 less than 10. And that's not true. 1 is not greater than 3, so it doesn't fit both of those, so I'm not going to shade there. Let me think of a number over here, like 5. Is it true for the 5? Is 5 greater than 3 and 5 less than 10? Absolutely. So I'm going to shade where that is. So basically I'm just looking at each region, I'm testing it out. And see, hey, do you work? And if it works, I'll shade it in. If not, I don't. The decision of 5 here was arbitrary. I could have used 6 or 4 or 7. That doesn't matter. Some number that's greater than 10. Anyone? Anyone have one? Yes? Yes, you there. Yes, good. 13, of course. Okay? Any number that's greater than 10, that's fine. So we're looking at 13. And putting that 13 in for x. Is 13 greater than 3 and 13 less than 10? Does it fit both of those? No. So it's just shaded in between for this and inequality. Okay. There's one more type, an or, and then I'll let you try a couple, and then I'll shut up for a while. So this or inequality, it has a little bit of work to do, so let me do that first. X is less than 10, or, and this one I have to subtract 3, x is greater than or equal to 17. I guess I did that kind of quick. So back to the beginning, my original problem said, look, 2x is less than 20, or x plus 3 is greater than or equal to 20 as well. It shows 20 twice there. I'm very unoriginal. So over here I had to divide by 2, and over here I had to subtract 3. So what I get when I simplify it a little bit is that x is less than 10, or x is greater than or equal to 17. And when I say or, that means it could be one or the other. It doesn't have to be both. And again, let me draw this out. This is usually looks like the opposite of a between. It usually looks like the two ends. So let me put a 0, a 10, or a 17. There we go. So when I'm testing out the regions here, it has to just fit one or the other. So let's look at 0. Well, is 0 less than 10 or 0 greater than 17? The or equal to part doesn't matter here, by the way. That's why I'm skipping that. So does it fit at least one of those? Well, yeah, it fits this one here. It's less than 10. So I am going to shade over here. Okay, let's look somewhere in the middle. You're somewhere in the middle. Let's try 14. Is 14 less than 10 or 14 greater than 17? Does it fit either of those, this or that? Well, the answer is no. 14 isn't less than 10, and 14 isn't greater than 17. So I'm not going to shade here in the middle. Let's look over here at 20. Okay, is 20 less than 10 or 20 greater than 17? Well, 20 is greater than 17. Because it fits one or the other, I'm going to shade up there. 95% of OR inequalities will look like this. It'll be the two ends going out. 95% of them. Every now and then they'll throw one at you that doesn't, and we'll do one of these in your try it is going to be a little weird. But 95% of them are going to look like that. Okay, let me give you a couple try-its. Okay, your first step with both of these is to solve for x if you need to, and then plot the 2 points. And then if you're not sure from there, we'll try it out. But go ahead and see what you can do.